Our planet is warming, glaciers are melting, sea levels are rising, and extreme weather events are becoming more frequent and severe. The culprit? Greenhouse gases, primarily carbon dioxide, released from human activities like burning fossil fuels for energy. The urgency of the situation demands immediate action. We need to drastically reduce our reliance on fossil fuels and transition towards cleaner, renewable energy sources like solar and wind power. Amid this challenge, a glimmer of hope emerges: carbon capture and storage, or CCS. This innovative technology intercepts CO2 at its source power plants, factories, and other industrial facilities, and prevents it from entering the atmosphere. By preventing its release into the atmosphere, CCS acts as a crucial tool in mitigating climate change, buying us valuable time as we transition to a cleaner energy future. The world is awakening to the urgent need for a clean energy revolution. While the transition to renewables is well underway, it will take time to fully replace our dependence on fossil fuels. This is where carbon capture and storage steps in, allowing us to continue utilizing existing energy infrastructure while significantly reducing the associated carbon emissions. Time is of the essence when it comes to climate change. Even if we were to cease all greenhouse gas emissions today, the planet would continue to warm for decades due to the emissions already accumulated in the atmosphere. CCS offers us a means to achieve immediate emissions reductions, providing a lifeline as we navigate the complex and time-consuming transition to a low-carbon future. Addressing climate change requires a multifaceted approach. We need a combination of both, accelerating the development of renewable energy sources and solutions to address the emissions we're producing right now. By capturing CO2 from industrial processes and power plants, CCS prevents these emissions from contributing to further warming. The Earth's atmosphere is a delicate balance, disrupted by unprecedented emissions of greenhouse gases. The consequences are already being felt worldwide: rising sea levels, more frequent and severe heat waves, intensified storms, and disruptions to ecosystems. Amid this urgent need for action, carbon capture and storage, or CCS, emerges as a powerful tool in our fight to stabilize the climate. The world's energy infrastructure is a complex web, largely reliant on fossil fuels. Transitioning this vast network to cleaner, renewable energy sources is a monumental task. CCS offers a remarkable degree of flexibility, allowing us to decarbonize our existing infrastructure without having to build entirely new facilities from scratch. CCS offers an intriguing side benefit: enhanced oil recovery, or EOR. Injecting CO2 into depleted oil reservoirs can significantly enhance oil recovery rates, while also permanently storing the injected CO2 underground. This dual benefit of EOR makes CCS particularly appealing from both an environmental and economic perspective. Technological advancements often come at a cost, and the fight against climate change is no exception. Building and operating CCS facilities is an expensive undertaking, requiring substantial upfront investments and ongoing operational costs. However, the environmental and societal costs of inaction on climate change are far greater than the financial investments required for CCS. CCS, while designed to reduce carbon emissions, presents a perplexing paradox. It requires energy to operate. This energy demand can potentially offset some of the environmental gains achieved through emissions reductions. Researchers are actively exploring ways to improve the energy efficiency of CCS technologies to maximize its environmental benefits. The threat of leakage represents a significant concern surrounding the long-term viability of CCS. Ensuring the long-term integrity of CO2 storage sites requires rigorous site selection processes and continuous monitoring. Developing robust regulations and industry standards for CO2 storage is crucial for minimizing leakage risks and ensuring the public's trust in CCS as a safe and effective climate change mitigation technology. Section 1. Striving for affordability. The promise of carbon capture and storage hinges on its ability to become a financially viable solution for reducing carbon emissions. Currently, the high costs associated with CCS, from capturing CO2 to transporting and storing it, pose a significant barrier to its widespread adoption. However, just as solar and wind power have witnessed dramatic cost reductions in recent years, so too can CCS become more affordable through technological innovation and economies of scale. One promising avenue for cost reduction lies in developing more efficient CO2 capture materials. Current capture technologies often rely on amine-based solvents, which, while effective, require significant energy for regeneration. Researchers are exploring alternative materials, such as metal organic frameworks and ionic liquids, which offer the potential for lower energy consumption during the capture process. Another area ripe for innovation is the transportation of captured CO2. Pipelines, while efficient for transporting large volumes of CO2 over long distances, require significant upfront investments. Exploring alternative transportation methods, such as using specialized ships or even converting CO2 into stable, transportable forms, could offer more cost-effective solutions, particularly for smaller-scale CCS projects or those located far from suitable storage sites. Moreover, as the CCS industry matures and gains experience, economies of scale can be realized. Just as mass production led to lower costs for solar panels and wind turbines, so too can large-scale deployment of CCS technologies drive down costs through learning curves, standardized designs, and increased competition within the industry. Section 2. The efficiency imperative. The effectiveness of CCS in mitigating climate change depends not only on its ability to capture and store CO2, but also on its overall energy efficiency. Currently, the energy required to operate CCS technologies, particularly the capture process, can offset some of the environmental gains achieved through emissions reductions. Improving the energy efficiency of CCS is therefore crucial for maximizing its climate benefits. One approach to enhancing efficiency is to integrate CCS with industrial processes that produce waste heat. Cement production, for example, generates significant amounts of heat as a byproduct. This waste heat can be harnessed to power the CO2 capture process, reducing the overall energy demand of the CCS system. Similarly, integrating CCS with combined heat and power plants, which generate both electricity and heat, can improve overall energy efficiency. Another promising avenue for efficiency improvements lies in exploring novel capture technologies. Membrane-based capture systems, for instance, offer the potential for lower energy consumption compared to traditional amine-based systems. These membranes act as selective barriers, allowing CO2 to pass through while blocking other gases, reducing the energy required for separation. Furthermore, optimizing the design and operation of CCS facilities can yield significant efficiency gains. This includes minimizing energy losses during transportation, developing intelligent control systems that optimize capture rates based on real-time conditions, and exploring the use of renewable energy sources, such as solar or wind power, to power the CCS system, further reducing its carbon footprint. Section 3. Policies for a sustainable future. Technological advancements alone are insufficient to drive the widespread adoption of carbon capture and storage. To unlock the full potential of CCS in mitigating climate change, supportive policies and regulations are essential. Governments play a crucial role in creating a favorable environment for CCS deployment by providing incentives, establishing clear regulations, and fostering international collaboration. One effective policy tool is carbon pricing, which internalizes the cost of carbon emissions, making polluting activities more expensive. This can be achieved through carbon taxes or cap-and-trade systems, both of which create financial incentives for industries to reduce their emissions. CCS, by offering a way to decarbonize industrial processes, becomes a more attractive investment option under carbon pricing mechanisms. Governments can also incentivize CCS deployment through direct subsidies, tax credits, or other financial incentives. These mechanisms can help offset the high upfront costs associated with CCS, making it a more financially viable option for industries considering emissions reduction strategies. Additionally, governments can support CCS research and development through grants, public-private partnerships, and the creation of dedicated research centers. International collaboration is also crucial for accelerating CCS deployment. Sharing knowledge, best practices, and technological advancements across borders can help overcome technical challenges, reduce costs, and promote the harmonization of regulations. International agreements, such as the Paris Agreement, can provide a framework for collaborative efforts on CCS, fostering a global commitment to combating climate change. Engaging the community. Community engagement is crucial for deploying carbon capture and storage technology. Building trust and fostering understanding among local residents is paramount. Open and transparent communication is the cornerstone. Proactive engagement provides clear and accessible information. Public forums and online platforms foster dialogue and address questions. Addressing safety and environmental concerns builds trust. Independent assessments and monitoring plans provide reassurance. Engaging local communities fosters ownership and shared responsibility. CCS projects create economic opportunities for local communities. Job creation and community benefit agreements generate tangible benefits. Prioritizing community engagement makes CCS projects catalysts for positive change. A global imperative: collaboration for climate action. Climate change knows no borders. It's a global challenge demanding a united global response. Carbon capture and storage transcends national boundaries and necessitates international collaboration. By working together, sharing knowledge, and pooling resources, nations can address the climate crisis. International cooperation can take various forms, from sharing research to establishing common standards. Joint research projects and technology transfer agreements can accelerate innovation and reduce costs. Harmonizing regulations for cross-border CO2 transport can facilitate international CCS projects. Financial mechanisms like the Green Climate Fund can support CCS projects in developing countries. Capacity-building initiatives can empower developing countries to adopt CCS technologies. The climate crisis demands a collective response, transcending political differences and geographical boundaries. By working together, sharing knowledge, and supporting each other's efforts, nations can harness the power of CCS for a sustainable future. Sustainability, a tapestry of solutions. In the intricate tapestry of sustainability, carbon capture and storage emerges as a vital strand. CCS complements renewable energy, providing a bridge to a cleaner energy system. By integrating CCS, we can accelerate our progress toward a carbon-neutral world. A tool in our arsenal. Carbon capture and storage is a vital tool in our collective arsenal. Likened to a high-tech vacuum cleaner, CCS intercepts harmful carbon dioxide emissions. The urgency of the climate crisis necessitates a multifaceted response. It's about recognizing the value of each approach and integrating them. Just as a craftsman uses various tools, we must employ diverse solutions. Imagine CCS as a bridge, allowing us to reduce environmental impact. This bridge provides time for renewable energy sources to scale. It's about ensuring a smooth transition to a cleaner energy future. Towards a sustainable future. The pursuit of a sustainable future requires a paradigm shift, a move away from short-sighted thinking towards a more holistic approach that considers the interconnectedness of our actions and their long-term consequences. CCS embodies this shift, encouraging us to view carbon emissions not as an inevitable byproduct of progress, but as a challenge to be addressed, a resource to be managed. Just as we strive for circularity in our economies, aiming to minimize waste and maximize resource utilization, so too can we apply this principle to carbon. CCS, by capturing and storing CO2, prevents it from entering the atmosphere, transforming a harmful waste product into a resource that can be used for enhanced oil recovery or even converted into useful products. This shift in perspective requires collaboration, innovation, and a willingness to invest in long-term solutions. Governments, industries, and communities must work together to overcome the technical, economic, and social challenges associated with CCS deployment. It's about fostering a shared vision of a sustainable future and recognizing that collective action is essential to achieving this goal. The path to a sustainable future is not without its obstacles, but the potential rewards far outweigh the challenges. By embracing technologies like CCS, investing in renewable energy sources, and adopting more sustainable practices, we can create a world where economic prosperity and environmental stewardship go hand in hand, ensuring a brighter future for generations to come.